Hi guys, welcome to Ramanujan.math.circle, and today we're going to start off with our first topic, systems of equations in this AMC10X 101 series. Systems of equations is really pervasive throughout the AMCs year after year, whether it's a beginning of the test or the end of the test. So we're going to look at a broad range of different kinds of systems of equations problems, whether it's in covering during the lecture, during the examples that we go over, the exercises, or even the quiz. So without further ado, let's get into systems of equations. All right, so generally when we have something related to systems of equations, we have multiple variables that we're solving for. And the very popular one in math competitions, particularly AMC at the beginning, would be some sort of word problem, which can be converted into systems of equations by assuming some variables and setting the some variables equal to some people or different objects. And then you solve your equations and then find the values. In these problems, obviously, we're being careful in realizing what we're solving for and different things like that. So that's one style. Another style is when they just give you a set of equations, like sets of equations, and you have to manipulate them, work around with the equations to help solve for something, whether it may be for one of the variables, or whether it may be for the sum or the product of the variables. So it could be various different things. So we'll kind of look into some of those examples over the course of this lecture. All right, so obviously everything has a set of methods to help solve it. So let's look into some of the methods that we can use to solve systems of equations or linear equations in particular, which are more popular. So we have the very famous Gaussian elimination, which many of you might know as elimination. We have that for generally systems of equations where it's very oftentimes linked with converting a word problem into two different equations, and then you just work around with it, which we'll go over in the next slide, I believe. We have substitution, which has to do with taking one variable, isolating it, finding the value of it in terms of the other equations, and substituting it back in, which is where its name comes from. And this turns out to be by far one of the most powerful techniques, whether in solving systems of linear equations or solving systems of equations in general. And so that's something you want to pay attention to, definitely, of using substitution. Then we have graphing. Graphing is quite time intensive. You have to use a lot of thought and draw things out because obviously you don't have graphs on AMC to draw it on, but it can definitely be useful when you are trying to find the number of solutions to a certain equation or function, which we'll go over in the next week. And we would obviously avoid graphing when it comes to finding an exact solution, although we will go over one very basic example to solve stuff using graphing, but it's one that you want to avoid when it comes to finding the exact solutions. And then we have, last but not least, but very powerful tool of symmetry, which is by far one of the most most used things in contests like AMC, because you exploit the fact that certain variables are arranged in a symmetric manner. And we'll kind of look into this idea or this perspective as we go through the lecture. And oftentimes you combine symmetry with some of the other methods that I mentioned before, or maybe more other kinds of slide techniques to solve a question. So without further ado, let's get into our first method, which is Gaussian elimination, also known as elimination to most people. All right, so Gaussian elimination is when you have variables and you add constant multiples of one system to the other and solve for the variables. So we'll look at a very basic example that we have over here, which has to do with two systems of equations. So the question asks, find the ordered pair x, y for which x minus 12y is equal to 2, and 3x plus 6y is equal to 6. So now let me like walk through the steps of how to apply Gaussian elimination or elimination to this set of equations. So first things first, we would like to eliminate a variable. And the way we're going to do that is we're going to multiply one of the equations by some, actually we're going to multiply both of the equations by a number, such that if you add the two equations or subtract the two equations, you can kill off one variable in practicality. So let's look at how that's going to work. So we have that x minus 12y is equal to 2, and 3x plus 6y is equal to 6. So one thing we realize is that 6 times 2 is equal to 12. And how we're going to use this fact is that we're going to multiply this equation by 2, and we're going to multiply this entire equation. Remember, the right side and the left side need to be multiplied by the same number in order to keep the equation the same. So we're going to multiply this one by 1. Okay, now let's write out our new equations. So x minus 12y is equal to 2. So that stays the same since you're multiplying the entire thing by 1. And then you get 6x plus 12y is equal to 12. Okay, so that's relatively straightforward. Now what we're going to do is we realize that if you add the two equations, you get rid of essentially the y. So let's add the two equations together. And adding the two equations gives us 7x because we do x plus 6x plus 0y is equal to 14. And obviously 0y is ignored. So that basically gives us that 7x is equal to 14. And dividing both sides by 7, we get that x is equal to 2. What are they asking for? Remember, always look back to what the question is asking for. They're asking for the ordered pair x, y. So if I were to box my answer as is right now with x equal to 2, I would actually get my answer wrong because they're asking for both the x and the y value. So what we're going to do in this is we're going to plug our x equal to 2 back into the equation to either of the two equations, since this is something that has to satisfy both of them. I'm going to just substitute it into the first one because that's the first one there. So 2 minus 2y is equal to 2. So what does that give us? Well, y, I guess it's just like negative 12y is equal to 0, and y is equal to 0 because of that. Okay, so our ordered pair x, y is equal to 2, 0. Now that's my final answer. And in essence, what you're doing is trying to find a way to kill off one variable by multiplying the equations by a certain number. And now with like the more formal solution right here, which is basically what we did, and we found out the variables, we found out the values of the variables, and we have our answer. So that's about Gaussian elimination. Now let's move on to the powerful substitution method. Substitution basically involves solving for one variable. You're going to isolate one variable and get it in terms of the other variables, and then taking that value and plugging it back in. So in essence, let's look into an example in order to demonstrate this, this method of substitution. So here we have a word problem. So like I said before, word problems are really popular in the beginning of AMC in order to represent a systems of equation. And so what we're going to do is read the question and convert this word problem into multiple equations, and then we're going to work on solving it. And guys, remember one thing is that when you have some sort of variables, it's important to make sure that you know what each variable means. Because in this case, I can say that, okay, Selena's mom, Alexa, right, as we're going to have it, could be named as X. And I might not know whether that's Selena or her mom. So it's important to know, either you can make a note of what you're naming each variable, like what each variable stands for, or you could just make it such that it's more than evident. And that's how I'm going to work for this one. I'm going to pick a variable that is more than evident that it belongs to Alexa or Selena. So in essence, what we're going to do is read the problem first, and we're going to write equations for it. So Selena's mom, Alexa, was 5 times as old as Selena 5 years ago. So I'm going to read this first sentence and convert it into an equation. So what we're going to do is we're going to say, okay, Selena's mom, Alexa, so Alexa, I'm going to call it as A, and was 5 times as old as Selena 5 years ago. So realize what this means is that we're not right now, but we're going back in time 5 years ago. And what I'm going to do is I'm going to let A equal to Alexa's age now. And S is equal to Selena's age now. Okay? So in essence, that means since we're talking about 5 years ago, we need to subtract 5 from Alexa's age on the left side. And now we have to talk about Selena's age. So Selena's mom, Alexa, was 5 times as old as Selena 5 years ago. So what we're going to do is multiply 5 by Selena's age. However, remember that we're talking about this 5 years ago. So what we're going to do is we're going to put a minus 5 here and multiply the entire thing by 5. Because Selena right now is S years old, so obviously 5 years ago she was S minus 5 years old. So now that's our equation. Okay, that's our first equation. Let's write it down. And now let's look at our second sentence, and we're gonna find our second equation from there. In 3 years, Alexa will be thrice as old as Selena. Okay, so in 3 years, that means A plus 3, correct? Because right now Alexa is A, and in 3 years she'll be A plus 3 years old. And thrice as much as Selena's age. So S plus 3, because obviously Selena is S years old right now. In 3 years, she'll be S plus 3 years old. That's our second equation. All right, so they're asking for the sum of Alexa and Selena's ages, so they're asking for A plus S. Okay, that's not too bad. We could definitely deal with this. It looks doable. There are 2 equations and 2 variables. We should be able to solve this. And one thing, as I said this out loud, I realized that I should explicitly state this, but when you have some amount of variables, you need to have that many number of equations generally to say that, okay, yeah, there's one specific solution. If that isn't the case, then there might be no solutions or more solutions. We can talk about that later. But basically, we have 2 equations, 2 variables, we can solve this. All right, so yeah, looking at that, our equations are matching with the answer. Now let's look into the next step, which is using substitution to solve this question. Okay, so what I'm going to do right now is recopy. Okay, so what we're going to do right now is copy down the same equation again. So like the 2 equations that we got. So again, it was A minus 5 is equal to 5 times S minus 5. And it was A plus 3 is equal to 3 times S plus 3. Okay, so now we're going to use substitution. And one thing I want to make sure that's clear is that we have the 5 multiplying with the entire S minus 5. So we're going to multiply this out completely. So this is 5S minus 25 is equal to A minus 5. And we're going to do this as a second equation as well. We're going to let this expand to 3S plus 9. And now A, so now we could add 5 on both sides. So we get A is equal to 5S minus 20. And then for the second equation, we subtract 3 on both sides. So we get 3 S minus, or 3S plus 6. All right, so we've got our equations. Now, how do we substitute? And the way we're going to do this is we have the value of A in this equation. A is indeed equal to 5S minus 20. So what we're going to do is we're going to plug in that value into, so 5S minus 20 instead of A in the second equation. And we're going to put this side is equal to 3x. 6. and that's equal to A. Okay, so now forget about this A over here. We're just going to focus on the last two parts. So 5s minus 20 is equal to 3s plus 6. Now it's just solving in terms of a variable. You get that 2s is equal to 26, so s is equal to 13. And remember, we're asked for a plus s, so we want to look for a as well. And for that, we're just going to plug it back in. So 3 times 13 plus 6, which is equal to 39, plus 6, which is equal to 45. Okay, and they're asking for a plus s, which would be equal to 45 plus 13 is equal to 58. And for those of you that have time left over during competitions like AMC, it's definitely useful to plug this back in to the equations or to like the question itself to make sure that that works. And we're just going to do that quick check right now since we have time on our hands. We're going to say, check that, okay, Selena's mom, Alexa, was 5 times as old as Selena 5 years ago. So 5 years ago, Selena was 8 years old. And Selena's mom was 5 times as old as that. So she was 40 5 years ago. That makes sense, right? Because now Alexa is 45 years old. Back 5 years ago, she was 40. So that works. The first part works. So let's check that off. Now this is the second sentence. So in 3 years, Alexa will be thrice as old as Selena. Selena in 3 years will be 16 years old. And 3 times that would be 48. And indeed, in 3 years, Alexa will be 48 years old. So that also works. So at the end of the day, we see that, okay, 45 and 13 match, they work, and we get our final answer. So like, let's take a peek at our answer. Yay, so we got 58.